Introducing the tech demo on AI audio deepfake creation from our AI SecOps podcast with Derek Banks.
How easy is it to create a deepfake? So, from an audio perspective, we're just going to talk about audio and not video in this segment. And so, I feel that in kind of trying out a bunch of different projects that. From a maturity perspective, the audio seems to be a little bit better than video at the moment. So maybe a future segment will have some deepfake video in it. But for now, we're just going to focus on audio. And so it turns out there's a couple of different kind of mature projects out there. We're going to talk about one that's called F5 TTS, which is just out on GitHub. And let me share my screen. And so F5 TTS stands for a fairy tailer that fakes fluent and faithful speech with flow matching, which is quite a lot to say. So we'll stick with F5 TTS. And so what this is, like Brian mentioned earlier, this isn't a GAN. This is a diffusion model. So essentially, there's a transformer with a convolutional neural network in front of it. And that CNN takes input data and helps align it to the audio better. There's a lot of math happening there. We're not going to go into that. So essentially, this is kind of a more complex, deep neural network than just two convolutional neural networks. There's a couple of different ways that you can install it. And so first, what you want to do is create a Conda environment, or you could use Python virtual environments. I prefer Conda. The reason for this is that if you've done any kind of Python and data science work, you probably have already been in dependency hell in the past. So if you notice, we're going to Conda create a name F5 TTS and use Python 3.10. The reason that we're doing that is because this has some dependencies that are broken in 3.11 and 3.12 and 3.13. And so we're going to stick with the versions that work. And so it has support for different types of GPUs. I'm on a MacBook, so we're going to use the Metal Shader platform or Apple Silicon. And it's really just two pip packages that we need as dependencies, Torch and Torch Audio. And then we're going to pip install right from the GitHub link. We're going to do the inference install. You can also do an install where you can have the editable install, where if you wanted to get into fine-tuning the model or some kind of training, like additional training, you could use that. We're really interested in just running our inference of the model. So we're just going to take the pre-trained stuff that's already published with this and use it to generate our speech or our deepfake. There's also a Docker build, and we're going to use the web app portion, or the Gradio app, which is kind of the default way that they say to run it. And so you launch that with F5-TTS_infer-Gradio, and it'll launch an application that is running on TCP 7860 locally in your environment. Now, there's a couple of different options that you have here. First, you can choose which model you would like to use. The F5-TTS, E2, or a custom one. We're going to stick with the default. And the basic TTS mode, you're going to drop an audio file in and just create, new audio from the speech that you're going to, or the text that you're going to put in. You can also create multi-speech or kind of a conversation between two different deepfakes. There's a voice chat where you can load a chat model and then have a conversation with it using your reference voice. And so we're going to just demonstrate the basic portion of this. And so the first step in any kind of data science project is to go gather your data that you want to perform actions on. And so in this case, I already have downloaded some audio from Brian Fairman. From his earlier tech segment. I was able just to go get the WAV file from his earlier tech segment on prompt injection, and it's about 10 minutes long, and I'm going to go ahead and drop it into here. It's going to process it quickly, and let's take a quick listen.
And so let's hop into a demo on prompt injection.
Okay, so sounds like Brian to me. And so what we're going to do is pick some text to generate. So I'm going to go with, yes, 16. exclamation point. That is my new catchphrase. New catchphrase that I am trying out, like the Macarena. I am convinced that it will be the next viral phrase to sweep the nation. Also, here is awesome. All right, so we're going to synthesize this. Now, one thing you're probably going to notice, so we're just going to convert audio, and what it's doing here, we only really need 15 seconds of audio to generate from our text, which is kind of terrifying if you think about it. And then it's going to send that text to our convolutional neural network and then the diffusion network, and out the other end is going to come audio that is going to hopefully sound like Brian Fairman and saying our text that we tried to generate. And so we're still at 0 of 2 steps. On my MacBook, my M2 Pro, this takes probably, I'd say, a minute or so. It should be done momentarily. There's no Jeopardy music play. Here we go, 50%. So 1 of 2 steps, almost done. Perhaps I should have tried a smaller sentence. And there we go. All right, so let's check out what it sounds like.
Ah, yes, sick beans. That is my new catchphrase that I am trying out. Like the Macarena, I am convinced that it will be the next viral craze to sweep the nation. Also is awesome.
Oh, man. It didn't have my name in there. So wasn't quite perfect. You could tell by some of the inflection that it was maybe generated, maybe some of the pauses. But man, it really does sound like Brian, in my opinion. So, yep, that's really all it is to it, to create an audio deepfake. And so, as Joff mentioned, if you go trying this out, just stay safe out there.